So let us continue and probably end this two modules which are left with us. And as I said already that this particular segment involves primarily the standards and the different evolutions of wireless systems, along with some advanced topics on which people are working on. So both of these modules, as you can see, it's only 3 hours per class. Like 3 hours means like basically 2 weeks, but we will finish it off before that itself. And mostly in this segment, you are supposed to get mostly theoretical questions only. So we'll touch upon based on that, and accordingly we'll see how much it goes. Now, if you see the standards over here, the first module, which is the module 3, uh, primarily deals with the different generations from AMPS to LTE. Now, if I tell you in general, so AMPS ideally it starts from the 1G generation, and you can say LTE 5G is more or less 5G and beyond. So this is the span of generation wise how it has evolved. Now, evolve means like it has evolved in terms of the frequency of operation, the spectrum, the bandwidth on which they are working on, the number of user it can handle, the multiplexing techniques that they are providing with. So all of them has some basic advantage, or you can say great upgradation compared to the previous one. And so we'll try to touch upon that. Along with that, the architectural differences, how it changed. Okay, so that will also be discussed. But remember one thing: in all of these standards, is AMPS to GSM to GPRS, H and LTE, the most important fundamental architecture, if you say, is compared to GSM. Because you will soon find that the GSM was the first of the standards where the architecture that, like the one that we are discussing right now, the main basic skeleton of the architecture for a wireless scenario or for a mobile telecommunication, it is being based on the GSM architecture. It just went on add on things on top of it in order to cater the need of that particular generation. Correct? So keeping that in mind, let us try to find out what exactly is AMPS, because AMPS happens to be the starting point of all this mobile communication that we come across. Now, what we look into over here, you can see that this is the first generation analog cellular radio communication. Now, this is a very important word, as you can understand that the most of the things that we do it right now, they are digital in nature. And this was the first advent where it was typically used by an analog system. Because if you in the next slide, I think we have the comparison. I'll just show you that comparison maybe, so that it gives you an idea about the range and all. So you can over here what happened, if you observe here in this table, that AMPS starts at the first column, and it is primarily mostly being popular in the North America. All right. And it has a particular operating bandwidth. We'll touch upon this later. But if you observe carefully, one very interesting thing is happening, that for different region, there are different standards which are available, which were available. All right. So as if you remember, I don't know whether you remember it correctly. When we started off with this course, I told you, when I was telling you the comparison of the different generations, in that I also had shown you the same thing. You can see over here that for different countries, you have different bandwidths and you have different standards of channel capacity, channel spacing, or data transmission rate for that matter. Now, this becomes a very crucial point because there is no common standard that is available throughout globally. In fact, that is one of the reasons why AMPS will not be so much popular like a GSM. Because GSM happens to be a global system. It's a global standard all throughout. Okay, so that is basically one of the biggest advantage of AMPS to GSM. But we'll come to that. So let me go back. Let me go back to the previous one again. So you can see over here, the first thing that came up is that it is analog in nature. And naturally, in analog, you can see typically it serves, the radius is between 2 to 25 kilometers, which is significantly smaller if you say compared to where we are right now, or even for GSM, we will observe that the distance can be anything for that matter. So this was around the around the year of 1970s and early 75 like that. It is not that it was in 90s. So it was still in the nascent stage. So people were trying to experiment on it. It had the medium power, which is around 100 watt of transmitter, which is fairly very high. If you observe over here, 100 watt of transmitter at cell sites and low power of around 4 watt. But eventually this powers also, if you try to emit, as well as if you have carrying a device which is actually reading this much of power, it is not a very sufficiently capable device. The battery will drain out soon. All right. And the device will be also very big. That's why the early stage of the development, you will observe that it will be a very bulky and a very high drained devices. We needed to charge more along at that point. So that was one of the features. The second one is that the system is it was aimed to have a blocking probability of around 2%, which we know that from call blocking probability as we have seen, but it is during the busy hours. So this was a very good set of call blocking, we can say that that is what they were trying to achieve. And also you can see these terms are very known to you: 7-cell frequency reuse, which is basically n equal to 7, if you remember the first module we discussed, and also 120-degree cell sectoring, which was also used. If you remember the sectoring reason, the sectoring, how we do the sectoring and all. So that same thing, sense specifications were also given over here. Also cell splitting techniques, if you remember, the bigger cell divided into smaller cell with respect to R and R by 2. So that also can be considered over here, and it increases the user capacity. So you can see these ideas, the cell sectoring, the frequency reuse, the cell splitting, all these ideas are actually coming in the GSM as well. It is extrapolated to GSM as well. Alright, so these some of the concepts were taken care of in GSM, except for few more fundamental change, which I'll tell you after some time. So the standards, again, if I go back to the standards, the main problem with this is that you have different standards or different specifications based on the region. There is no common platform to it. That's the main problem. All right. But still, as we are discussing only AMPS, we are not discussing about the TAC or NMT. NMT means nomadic. M stands for mobile telecommunication, most probably. The full forms are different, actually. So all of them are full form, but as in our syllabus, we only have AMPS. So we are only focusing on the AMPS and its standards. So preliminary, the standards that we come across is that these are the range of frequency. I want all of you to at least note or at least remember the range of uplink and downlink for AMPS. The reason is that you will soon find when we go to GSM, which is basically our main focus of attention, you will observe that there also will have an uplink and downlink which will be very similar to this. Okay, very similar range it will be. But the specification of some of the elements will be different. So you can see over here the system operates at 800 frequency range, which again in GSM will be changed to 900 megahertz. If you remember all the questions that we have solved, all the examples that we have solved, they were part of 900 megahertz frequency band. But this is 800 megahertz frequency. Mostly that is because the maximum you can see it is 894 megahertz. All right. Now the frequency, the frequency spectrum of 40 megahertz width. Okay. So you can see over here the 45 megahertz. If you observe here that between 824 to 869, if you see the difference. So what is the difference between this? What is the difference between this 869 minus 824? 40? 45. So that's why I mentioned there that the duplex spacing is around 45 megahertz over there. Okay, so this difference, the lowest value of the uplink and the lowest value of the downlink, they are separated by a 45 megahertz gap. So that is also been mentioned over here. You can see the duplex spacing between the cell site and the mobile transmit frequencies are at 45, because this uplink and downlink ideally is basically when the base station is sending you the signal or the user to the signal. That is basically your downlink, and uplink is when you are sending it to the base station. So that is basically your uplink. So those difference is basically 45. This is like standard. Is no hard and fast rule like why it is, but it is for standardized in that order. All right. Second thing is you can see the system uses a channel spacing of 30 kilohertz. So channel spacing is very small actually. 30 kilohertz is a very small channel spacing and narrowband FM modulation, whereas the frequency deviation is around plus minus 12 kilohertz. Now this 30 kilohertz will also change. In GSM it will change, but the basic structure of it will remain almost the same. Okay. Same again, the 30 kilohertz channel requires a signal to SNR of around 18 dB for a favorable outcome. If you remember again in cellular communication, in the first module when we discussed about the interference and the S2I ratio, there also we had given an example where S2I was considered to be 18 dB and we need to make sure that how much will be the cluster size so that it goes beyond 18 dB. So there also that 18 dB came up. The reason is because of that. Okay, so the reason is that this is how the standardized values are ideally for any scenarios like this. Next is you can see 10 kbps, which is a very, very small data rate. As you can understand that at that point when AMPS came up, and even in GSM you will find that the data rate is not a very important, significant factor over there. Because people never have thought that mobile device will be used in such a manner where we require such a high data speed. Mostly it was primarily for the communication from one point to another with a voice call. That's all. So that's why the data rate is not that significant or that much high, in fact, very low. And separate channels are used for transmitting the signal and controlling voice. This will be a little clearer later when we discuss about the GSM. But primarily these are my standards. So one thing you remember, one thing is uplink. First of all, it is an 800 megahertz band in which 824 to 849, this range belongs to mobile to base station, where you are uplink the scenario where I am the user and I am sending it to the base station. I think now since the NHSIM experiments and everything you have done already, so you must understand that user is connected to a base station. So that is basically my uplink where we are making a request and the base station is sending it back to another user. That is basically the downlink. So that uplink and downlink frequency band is given for the AMPS in this order. Alright. Next thing is, now this is again the same thing. Again, you can see the summary of whatever we have discussed so far here itself. So there is not much to discuss in this particular slide as such, but this is just a summary of it. Next is this one is important because there is one small equation to it which is used for calculation purpose. So one is that during the call, the mobile subscriber occupies two simplex channels. Okay, each one of them, one for the uplink, one for the downlink, because a communication needs to be established only when there is a uplink and downlink channel available, and they have a fixed duplex spacing which is 45 megahertz. Okay, so this is 45 megahertz. When a call is terminated or a handoff occurs, these terms are now pretty much familiar to all of you. The occupied channels are released and it can be used by other mobile stations as when is required. So multiple simultaneous mobile subscribers are accommodated in AMPS by allotting each calling and called mobile subscriber by a dedicated channel. I think we have already discussed long back when we discussed about the handoff strategies, when we discussed about the hard handoff, soft handoff, when we discussed about the allotment of network control or network assisted handoff or mobile assisted handoff. Okay, so those things are part of it. Even if you observe that we have discussed something called as channel assignment strategy, where we discuss about the fixed channel strategy, dynamic channel assignment strategy, hybrid channel assignment strategy. So all this have been discussed in the first module itself. Those are part of this discussion itself. Okay. Last, the one thing that is important over here is this equation. If you observe, this is specific to AMPS. So it involves the number of channels or N that can be simultaneously supported in an FDMA system. Okay, so this is specific to AMPS. The GSM, we have a different equation for it. So N is given by BT minus 2BG by PC. Now you can see over here what is BT. BT is the spectrum, total spectrum, which is allotted to us. Okay, we'll see that with a numerical, small numerical after this. BG is the guard band. Again, as you know, guard band is required because simultaneous transmission you are having. So guard band will definitely try to interfere, like lessen the interference amongst the users. And last but not the least, BC is the channel bandwidth which is available to us. So if I know about these three things, which is always a common thing for any such standard, we can find out what is my value of N. So let us take directly a numerical to understand this, simple example to make to understand. So these are some of the specifications. You can see US AMPS has allotted 12.5 megahertz for each simplex band. Alright, so that is basically my allotted spectrum. If you see over here, that's basically my BT. So 12.5 megahertz for each simplex band, it is provided. If the guard band at each of the simplex band is around 10 kilohertz, so you refer this allotted guard band is BG, which is 10 kilohertz, which is given. And the total channel bandwidth is around 30 kilohertz. These are all, this 30 kilohertz we have just discussed, this was a standard in AMPS itself. So there's no problem in that. So 30 kilohertz is the channel bandwidth. So if you know everything and if you substitute in this equation, you can understand that N is coming as 416, which means that the number of channels available are around 416 odd channel. So we can say intuitively that if given this standard or given this specification, there are 416 channels that can be allotted to the end user. And as you know that after this, the application of frequency reuse will come in, where we have to redundantly use the same channels again and again repeatedly, so that more and more number of users are used. Okay, so that is like very similar to the first part of our discussion in this topic of wireless communication, where we discuss about the frequency reuse, the optimal number of channels which are available, capacity, how you calculate C equals to MKN. If you remember those previously, same thing, but except that the equation is dedicated for AMPS. That's all, nothing else. Okay. Now, as I said, like although we are discussing about AMPS over here, I think we don't have the difference of it. I'll come back to this. But one of the biggest drawback, although we are discussing about all this and we are specifying that this many users can be accommodated, some of the major concern with AMPS happens to be one. As I already told you that it is not a standard across all the continent. It was never a standard across all the continents. So there was no coordination amongst the standardization, which is fairly a wrong idea, because you are imagining a scenario where you have a device which you are using in India, and suppose you go to some other place and you cannot use that, or even like so the spectrums are different, the standards are different, hence you cannot use them. So that is not a very profitable business for that matter. And second thing that was a major concern is that although we are providing a guard band, which we had told you over here, there was a major outrage which was happening because of the security breach. Because this AMPS as a standard, it doesn't provide that much security to the end user calling when it's happening, the call is going on. So basically there was no privacy. Okay, and there was a lot of data breach that were happening. And that is why the major concern that the security was not ensured, and hence it was not that popular anymore. So AMPS didn't go that much far, and people were very using a mobile communication or a mobile device for that matter because of this problem. Although these standards were there in AMPS, but nor AMPS or any of the others, NMT and NDD and all the other relevant standards, they also ceased to exist because they also had the similar kind of drawbacks. So that led to the second generation of our discussion, which is nothing but the GSM, which happens to be the 2G standard, which we all know. I want all of you to focus on this part because this is very, very crucial to discussing the other generations. Because GSM, as you can understand from the heading itself, the first term itself, is a global system for mobile communication. So this was the first thing that came up, that this is a standard which will be adopted by every country. So that's why the 900 megahertz that we come across, that will be common to every continent where we go, wherever we go. See, it doesn't matter much. Okay. So that is one of the very important things, because this is where the standardization started to have. Even if you observe now, like people are working on 6G and 5G standardization. That's again a common platform on which these standardizations are going on, so that it is a uniform standardization all throughout. Alright, so that is why this GSM became so popular. Alright. Now you can see over here, like around 85 countries, there is some history on it, but Ideally, it became very popular because of this standard. And second, it provided security also. Okay, it provided a very good security as well, which is one of the basic requirement when we are communicating or when two parties are communicating between them. All right. So these some of the things here along with this we already know. In fact, some of them you might be already are aware of. It's just the touching on these points as these are part of our discussion. So the first thing that comes in is called as the IMEI numbers. I think all of you already know what is IMEI numbers. I don't think we need to go ahead with much over here. IMEI number is the equipment identity, the unique identity identifier through which we can identify the equipment. Okay, so IMEI numbers you can find out in any of your device by the number *#06#, and you can find out that whenever we have two SIM card, which is mostly in our devices nowadays, you will find that there will be two IMEI numbers that will be associated. That's because when we have an equipment which is registered, when it has a valid IMEI number, every SIM card plus and valid IMEI number will be considered for every operator. A operator, if you even have a proper SIM card, but your device is not an authorized device, it will start to have a blockage. It will not give you the connection. Okay, the connectivity issues, the authentication will fail. Even if you have a valid SIM card, but you have an invalid IMEI number. Alright, so the IMEI usually is somewhere over there. You can see this is just a pictorial representation, but again, as I can see, you can find it out on your system itself. Alright, and the important part is that if you see over here, the IMEI is allotted the equipment manufacturer, which we don't know. As a user, we don't know about it. But this number gives you the idea that which operator you are registered with as well. And also, using IMEI, one can recognize the obsolete, stolen or non-functional equipment. I think these are also part of your understanding. I think in many of the movies you can come across that through these numbers, we track the device. So, similar of this element is, it's not that everyone can track it, but as per the rule, you cannot give out the details directly. Although this number that you are looking at, it is open, but ideally this is not the exact number. This is just a dummy number. With respect to that, there is an official original number which is stored with a network with which you are operating with. So that number is kept confidential. Only in a specific condition, those can be tracked. Okay, so that is one of the biggest advantage of having this IMEI. The next thing also, I think you are pretty much aware of, which is called as IMSI, which is called International Mobile Subscriber Identity. This is ideally the important part of our phone number, which we usually call it as a phone number. But although it is not exactly my phone number, but every phone number, suppose we have a 10-digit number, that is again a dummy number, which we are sharing with everyone. My number I am sharing with all of you so openly. That's simply because that number has a dummy or a original version which is saved in a networking database. Or even if you are sharing with me your number, is just an identifier. Okay, the phone number that you are carrying is just an identifier number. That's all. But the particular number has a exact number or a original part of the number is stored in the network, and that number is basically the IMSI. Okay, so IMSI usually you can see that also has three parts. Usually, it will have a mobile country code. It will have a mobile network code. So every network, for example, you have an Airtel SIM card, it will have a different code. Jio will have a different SIM card. So it will have a different digit code. And also you have a number. So this mobile subscriber identification that you are calling out, this is a specific number. Okay, this is a specific number which is again a 10-digit number. Very similar to the 10-digit what we are having. So accordingly, you can see there are total around 15 digits because 10 digits here, 5 digit here. So it's a total 15-digit number, which is basically IMSI. Alright, and this is kept confidential. This is not very easily you will get the IMSI numbers for you. Like IMEI, we can search. IMSI, you will not be able to search. Or even if you get it, it will be a dummy because the original will be kept with the network operator. Alright. So, this is about the IMSI. Mobile station can only be operated if SIM with a valid IMSI, if inserted in the equipment with a valid IMEI. So, IMEI and IMSI both together, if you have a valid device but an invalid SIM card, it won't allow. And also, if you have a valid IMSI but not in valid IMEI, it won't allow. At long back, I don't know whether you remember it not, but long back there was a scenario where there were a lot of Chinese mobiles which were available in Indian market. At one point where there was GSM mostly at point, and there was a huge uproar because those devices were not authenticated or it was not a proper, it doesn't have a proper IMEI numbers. So tracking of those devices became a very, very difficult job. So later on, the standardization came up in India. The TRAI started to regulate, and now you will find that all the devices that we are carrying, they are all standardized. They don't have anything like invalid IMSI or IMEI numbers for that matter. So the things have been sorted quite a lot now. Okay. So next part is the mobile subscriber identification. So you can see over here, this is the part. This is the part, IMSI is not made public, but MS ISDN, the mobile subscriber ISDN number, this is made public. This is basically your mobile number. This is basically your mobile number which you are sharing with everyone. Because you need to get authenticated. But suppose the network is talking to them, talking to each other. So the network will identify both the called and the transmitter and the receiver, the called party and the calling party, through the internal number of IMSI and IMEI. We'll see that in the architecture, how it actually works out. So you can see the real telephone number of the mobile or the mobile subscriber integrated service for digital network, the MSISDN. This is assigned to the subscriber such that mobile can have several MSISDN depending on the SIM card. So if you have two SIM cards, you will have two different numbers. That's why when we have a dual number, when we have Airtel and Jio for that matter, you will have two phone numbers. But the same two numbers are allotted to the same IMEI because I'm carrying one single device. So it is absolutely okay to use two SIM card and even more than that also. But usually for our phone nowadays, two SIM cards are primarily used. And in fact, those SIM cards are 5G enabled in that way. So with this concept, GSM distinguishes between subscriber identity and the number to call. Okay, so using this number, who to call, that details will come. If you are dialing a number, that number will also have an MSISDN. Based on that MSISDN, it will check the IMSI, check the IMEI, whether the intended called party has also has an authenticated device and all, and then only an establishment will be happening. The separation of MSISDN and IMSI helps to protect the confidentiality of the subscriber. Okay, so even if your MSISDN is known by someone and if he tries to catch hold of the IMSI, it can't be because IMSI is separate and MSISDN is separate. IMSI is a private number which is only there with the network operator. Even we don't know, any normal user will not be knowing it. Alright, they should not know it. That's the thing. Okay, so again, MSISDN also is very similar to the previous one. You can see. So again, we have a country code. You will have some kind of a 2-3 decimal figure of national operator destination code, and then you have a subscriber number. So you can see over here the 99. Suppose you have an example over here. It is, although it is in terms of the China is 86. So the country code is 86 over here. Then you have 139 as the national destination code. So for India also is the same thing. Suppose I am considering 9944658860. So that 9944 that you are looking at, this is a series of number allotted for the Airtel user. And this gives us a very interesting observation on how and where your original SIM card was purchased. From the number itself, it will give us an idea about which series the numbers are, and that particular series of number is allotted for which kind of subscriber. So for example, 9944, this is a SIM card that I purchased here in Vellore. Now, if you go back to TRAI's website, and you will find the 9944 series of numbers that is allotted for Airtel Tamil Nadu. So that's why I have been given one number like this. Similarly, suppose you have purchased your SIM card in your hometown, you can go and check that the first numbers will identify the particular operator for that particular region. That's how it is allotted. It is not that randomly it is generated. It is just a series. That series of numbers again is controlled by TRAI. So through that, we can identify the number itself. Okay. So this is about the MSISDN that we come across and the standardization. Now we come to the other part. You can see the comparison of it. So IMSI and MSISDN. Anyway, I think you got the idea. Please this is completely hidden. We don't know about the IMSI A or IMSI B. So if A and B are trying to call each other, they will share these numbers to them, with them, and each of them can call. But internally, network-wise, the network will try to detect about this IMSI, whether these are valid or not. They will not, this is just an identifier. This is just an identifier, but they will check this IMSI and the IMEI for that matter. Only then the connection will be established. Alright? So that is how the things usually work between the two. But to understand that, we have to need the architecture for that matter. I'll come back to that. This is another very interesting thing that happens. I don't know how many of you know it or not, but this is called as mobile station roaming number. Now, what exactly it is? It is something like you can like you can't visualize it ideally, but this is how it happens. That's, for example, I'll give you a simple example. I have my SIM card, as I said, it is purchased over here. Now, during the vacation, I'll go back to my Calcutta, my hometown. So at that point, for the 1 month that I'll be staying there, so my device, although it is connected or it is purchased, my SIM card that is, although it is purchased here in Tamil Nadu, I'll be there in Calcutta. So the Calcutta Airtel database will consider me as a roaming user. Not in roaming in the terms of not in the like the cost or extra tariff or anything, nothing like that. It's just that to get a hold of where I am or what are my log, how I am using my devices for the entire stay during in my hometown. Those things will be all logged in with respect to this MSRN. So MSRN, if you see, there is a specific register which is called as VLR or Visiting Location Register. Where exactly it is, we'll show you in the architecture. So VLR usually stores all this visiting location register. So whenever you are also, if suppose you, I don't know how many of you have a SIM card over here, but when you go back to for your vacation and you are going back home, that same hometown will have the specific VLR where your number will be stored for the entire duration. If you have not purchased the SIM card over there in your hometown, you will be definitely have a VLR which will store your number and your activity. Alright. So you can see the mobile station roaming number is a temporary location. Temporary because the duration that I will be staying, the number will be considered under VLR. But once I come out, VLR will send all the information back to something called as HLR or home location register. We'll see that later. It is assigned by the locally responsible visited location register or VLR. Calls are routed MS using the MSRN. Okay. Structure of the MSRN is again very similar to MSISDN. If you see, there is a number, subscriber number, there will be a national destination code and a country code along with it. Alright. Now, the last part of what we come across along with the component that we have is something called as a subscriber identity module, which is called as SIM card. Alright, this already you know, and you can see the dimension, how it has changed and evolved. Okay, so the basic objective is to make it smarter. Now the SIM card is of that small range of it, and as we have come across, it has come to micro SIM card. You know this all stuff, so I don't think we need much information on this. Last but not the least, where we end our discussion today is the basic GSM hierarchy, which is a very common thing that comes in our discussion, and that is the structure which is shown over here. Now, if you closely observe that the green colored part, which is the GSM network, if I say, it has few basic blocks. Okay, so the blocks will come to the detail later, but if you see that ideally there will be an MSC region. Now, since you have done the NetSIM experiment, you know that there is a single MSC through which a base station will be connected. So you can see over here the orange colored ones are the MSC region. So every GSM network can have multiple MSCs, but within every MSC there will be one base station controller. Every MSC will have different, first of all, every MSC will have something called as location area register. Okay, so there will be a location area, as you can see the yellow colored one. Okay, so location area means basically a cellular coverage, you can say in that way. Now, each of the cellular coverage or the location area will have multiple base stations, which are basically the cells. Each of the cell will have base stations. All the base stations are controlled by some kind of a base station controller, and multiple such base station controllers forms a cellular coverage. So multiple location area forms a MSC and multiple MSCs forms a GSM network. Alright, so this is basically the ideal structure of the hierarchy in which the GSM operates. But the advantage is that this hierarchy that you are looking at, it works for GPRS, it works for UMTS, it works for LTE and beyond. So that is the advantage of having a GSM architecture. The main advantage or understanding of the GSM architecture is so important because this establishes from one point to another. It is very important in that way. Doesn't change much. So we end up our discussion with the only one thing, which is the location area, which is a very interesting thing to happen. Let me just discuss that and let us complete. So location area is nothing but something like this. Okay, so location area is that every cell, if you say over here, the yellow and the green ones, they will have a specific identifier. You can see over here the bottom half, this again has been mentioned over here. So there is a code over here. For example, you can see this particular green area will have a location area which is 89. Whereas the location area, other one, the yellow one, will have an area of 100. So what will happen? The cells along with that 100 location, they will have an identifier. So the identifier is something like 404, then 49, then 100 and 50. So this is 50, 51, 52, 53, 54, 55. So you can see there are 4 components to it. So that is mentioned over here. The first part is the country code. So as if it is in India, if you see India, say Airtel, if I say, so for India it is 404. So that's why this 404 comes in. Then we have 49, which is basically the network code. This is Airtel. So must have made 49 as a standard value for the particular operator. So 49 remains constant. You can see 49 everywhere. Alright. Then you have the location area, which is again 100 over here, 100 over here based on the location area code. And the last part is the cell area. So the cell identity is changing. 50, 51, 52, 53, 54, 55. The same happens here as well. You can see over here 404 is same, 100 is also same, but here it is 20, 21 and 22. Now why it is important is that if you see the user who is starting from this point and it is moving, it is over here, it is moving somewhere over here, it is changing the base station. Very similar to the structure like the umbrella cell concept or the handoff when a user is moving from one cellular to another. Remember? So if it is doing that, each and every time the location area is getting updated. So by this location area updation, we can find out the route in which the user is moving along. Okay, so keep a track of the whole process, that how it is moving. This is basically the objective of this location area identifier. So whenever a user is at moving condition, this is what is being used. So you can see the details of this individual location area identifier is given over there. Alright. So based on that, so you can see over, if I go back a bit, so each location area has its identifier and it is usually giving us an idea about the roaming process, like the movement of the user from one point to another, how it is moving. And this part, if you see over here, these are the location area. So this yellow colored is basically, within this there will be cluster of location area. So that will be taken care of by those yellow elements. And this will be communicated to the MSC. If you go back to the diagram once again, you will observe that the location areas are connected via MS. So the architecture that, the hierarchy that I was showing you, this is the pictorial representation. Alright. So let us conclude on this note and we come back next day when we discuss about the GSM architecture. Thank you.